Lesson 4, Multiplication of Vectors. Multiplication of a vector by a scalar, that is, a constant. If a vector A is multiplied by a positive scalar k, the result is a new vector k times vector A, which is in the same direction as vector A. When k is negative, the new vector k vector A is in the opposite direction to vector A. Examples number 8. Vectors OA, OB, OC, OP, OQ, O arrow are such that vector OA is equal to this column matrix, vector OB equal to this column matrix, vector OC equal to this column matrix, and vector OP is equal to 3 times vector OA. Vector OQ is equal to 3 times vector OB. Vector O arrow is equal to 3 times vector OC. Take O as origin and draw the vectors on a Cartesian plane. Compare triangle PQRO with triangle ABC. Solution: the coordinates of ABC are 3, 4. You convert this from column matrix to a row matrix. This is for B, then this is for C. Vector OP is equal to 3 times vector OA. You multiply vector OA by 3 to get vector OP as the column matrix with the entries 9, 12. Vector OQ is equal to 3 times vector OB. You have these results. Vector O arrow is equal to 3 times vector OC. This is vector OC. You multiply it by 3 and you have vector O arrow. The coordinates of PQ arrow are 9, 12 for P. This is for Q and this is for arrow. The coordinates of A, B, C are this from the previous solution. The coordinates of P, Q, arrow, you have them in this form respectively. So you draw the two coordinates on the Cartesian plane. So this is point A. If we are taking point A as ordered pair, you have 3 for S, then Y is equal to 4. So this is 4, then 3 is in between 2 and 4. This is point B, this is point C. Then for PQ arrow, you have point P, S is equal to 9, Y is equal to 12. So this is 12 for Y. You have 9 in between 8 and 10. This is the ordered pair for Q, and this is arrow. Now we have to compare the two triangles. First comparison: triangle PQ arrow is an enlargement of triangle ABC with O as the center of enlargement. B. Each side of triangle PQRO is 3 as long as the corresponding side of triangle ABC. This is very straightforward. Look at point A. This is point A. Look at point P. You multiply this point by 3 and you have this result. Here, the same 3, you have this result. Here, the same 3, you have this result. If you find the area of the two triangles, you will observe that triangle PQRO is 9 times the area of triangle ABC. Example number 9, prove that the diagonals of a parallelogram bisect each other. Solution. We have this figure as a parallelogram. We have AB equal to CD, AD equal to BC. We have two diagonals, BD, AC. For AC, the midpoint is P, and for BD, the midpoint is Q. In the parallelogram ABCD, let AB equal to B and AD equal to A. And because AB is equal to CD, we have it that vector DC is equal to B and BC is also equal to A. AC. To get to C from A, you have AB plus BC. You have it in this form, and that is B plus A. If P is the midpoint of AC, then AP is half. Vector AP is half of vector AC, and you have it in this form. To get to D from B, you have BA plus AD. Vector BA is equal to minus vector AB, then plus vector AD, and you have minus B plus A. If Q is the midpoint of BD, then vector BQ, that is half of it now, BQ is equal to half of vector BD, and you have it in this form. It follows that vector AQ is equal to vector AB plus vector BQ. Vector AB is equal to A, so you have A plus vector BQ is this result. You add it here. If you open this bracket, you have these results. If you simplify these two terms, you have 1 over 2 times vector B plus 1 over 2 times vector A. If you factor out 1 over 2, you have this result. Thus, vector AP is equal to AQ. Therefore, P is equivalent to Q. Hence, the diagonal AC and BD bisect each other. Example 10. The coordinates of the vertices of rectangle ABCD are, you have coordinate A, B, C, and D with their respective end points. Find the coordinates of the images of A, B, C, D when the rectangle is translated by vector A, this column vector, B, this column vector, C, vector AC. Solution. So we are to translate the coordinates to get the various images. So to do that, you translate the given vertices with this column vector, and that is simply the addition of this vector to the various coordinates, corresponding elements to corresponding elements. So for the first coordinate, you have 1 plus minus 1, that is 0. 2 plus 3, you have 5. You move to the second one, 1 plus minus 1, that is 0. 5 plus 3, that is 8, and so on. You move to B part, you translate with this vector by adding it to the various coordinates. Let's check for coordinate A. 1 plus 3 is equal to 4. Then 2 plus 1 is equal to 3. You have that for the other coordinates. We need vector AC. You can use A, C, or this A and C. You will have the same results. Vector AC is simply 1 minus 0, that is 1. 8 minus 5, you have 3. If you try using parts B, 5 minus 4 is 1. 6 minus 3 is 3. Then you translate the various coordinates by adding vector AC respectively. Let's show for this. You add this column vector to this coordinate. 1 plus 1 is 2. 2 plus 3, you have 5, and so on. End of lesson 4. There is every need for you to be saved if you are not, because the Lord Jesus Christ is coming very soon. Some will be taken and some will be left. Live righteously and be prepared. Goodbye.